Okay, I just record the lessons, but I think last one the recording got some problem, so I didn't record the full thing. I already write the solutions on everything. I will just go through the ideas again, but I'm not going to repeat writing that again. So if we have three vectors, well, what we finished last lesson is here. Remember, we have three equations to solve our two variables, which is not good to just solve by using the first two. I still need to put m and n into the third one to check whether m and n satisfy the third one or not. If it satisfies, then I have solutions for m and n, then they are linear dependent. If we solve out from the first two and can't sub into the third one, then we say they are linear independent. So we have A, B, C like this, and then we say A, B, C, they are linear dependent. So we can set up the equation like C equals to PA plus QB. We're not using M and N for, we no longer use M and N in these two places because M and N already used in C. So we can set up equation like that. We have three simultaneous equations. And from the second one, we can see P equals to Q. Then we move up here, we can see M equals to minus 5P and N equals to 4P. Or it can be minus 5Q and N is 4Q. So the ratio, I'm just interested in the ratio. So the ratio equals to minus 5 over 4, which is easy here. And for the next one, if this jogger runs 9 due to the north, so from point O go north, let's reach point A, and then go 6 kilometers in the direction of northeast of 60 degrees, which is 60 degree here, and then run this direction by 6, and then further due east by 5 kilometers, which is up, reach point C. If I and J are unit vector for east and north direction, so we want to work out the position vector of OC, you can relate to the initial position. I must work out this one and this one. So if I can see that's 9, so this length must be 9, this must be 9. So here is 6, that's 30 degrees, so that must be 3, that must be 3 root 3. So that's 5, we already know that. So the horizontal is 3 root 3 plus 5i, and then the vertical is just 12j, 3 plus 9, 12j. Example 6 is a very important example because when we learn linear collinear exercise like later in the chapter, we need to use this again. So if you can read the question by yourself first, we have OD equals to MOA. We know OA and OB, they are the position vector. And then A equals to N loss of AB, OX equals to 2/5 of OE, XB equals to 4/5 of DB. If I want to express OX in terms of AB and MM, we know that OX equals to 2/5 of OE. We start with what is given us in the question. And what's OE? OE equals to OA plus AE. So when we do the plus, we want, for example, I want to say OE is what plus what. What I can do is I can just put something in the middle. For example, I put A in the middle. So that's just OA plus A. So, or if I put a B in the middle, that can becomes that wait, it just disappeared. Just wait a second. So if I put B in the middle, that's just OB plus B. Okay, that's how I find addition. And then if you can see, follow the steps, well, that's OA, AE equals to N loss of AB, and AB equals to AO plus OB. So after simplify, I will have this as my final answer. To do the same with XB, 4/5 of dB, and dB equals dO plus OB. We put O in the middle, and DOD equals MOA, so DO equals to minus M of OA. So we, after combination, we have this one. So C is the important part. We want to find M and N, but how we can find M and N? Okay, how we can find M and N? So we need to use set in part A and B, OX and XB. When we adding them, OX and XB, when we add them, I should get OB. So that's the equation I can set up first. So I use these two things adding together. So A, how many A we have? We have 2/5 1 minus N minus 4/5 MA. That's how many A we have in both. And then how many B we have? 2/5 N plus 4 and 5B. We have that many B. And this must equals to 1B. So we can have two simultaneous equations. The coefficient of A must be 0 because I don't have any A on right hand side, and I only have one B on right hand side. So 2 on 5 n plus 1 on 5 equals to 1. I can solve out n equals to a half, and I can sub a half into the top equation here to work out m equals to a quarter. Okay, have a good think about this question, which is really important. Okay, let's have a look at the next one. Next one, first of all, is what is a unit vector? Okay, this is a very important definition. A unit vector is a vector on the same direction of the original vector, but got a length of 1. Okay, got the length of 1. So if we can think about here, if that's a vector A, unit vector A will be here. So with length 1, but pointing exactly the same way as the original vector. So the formula to calculate it is that hat is means unit vector that equals to A divided by the length of this A. Okay, the length of this. So also how we can calculate the magnitude of a vector A. If it's 2 dimension, we just square the x and the y. We find the sum, we find the square root. But you have 3 dimension, we square all the 3 values, find the sum, and find the square root. It's kind of the same as complex numbers. Okay, it's kind of the same as complex numbers. We'll talk about this later, not in this exercise. We'll talk about that later. Let's have a look at the last dot point. If we have a vector, with 3 dimensions, well, that's how many I, j, and k. So we also can say that's the x-axis, that's the y-axis, that's the z-axis. So we can, like say, we have a point A here. We form angle alpha with the x-axis. We form the angle beta in the y-axis. We form gamma here with the kx-axis. So what's cosine alpha when we form the angle with the x-axis? We choose the value in front of I, so it's p over the length of this OA. That will be the cosine of this alpha here. Okay, same as the other two. So if we think about the y-axis, we take p, which is the j value, and we take r with the z-axis. Okay, it's all over this absolute of a. Okay, so all over the hypotenuse here. That's the OA. Okay, if we have a look at example 7, we have OA equals to 3i, OB equals to 5i, and OC equals to 5j and 4k for OC. Find in terms of ijk of DB. Okay, DB is parallel to OA, but in the opposite direction of OA. So that's negative 3i. So OD, okay, OD here. OD equals to OB plus BD. Okay, OB plus BD. OB is 5j, already know. BD is negative DB, which is 3i. So OD is 3i plus 5j. And then we have DF. Well, DF is this one. It's the same as OC. Okay, parallel and same direction of OC. So that equals to 4k. And then OF. What's OF? OF is here. OF equals to OD plus DF. Okay, I know OD. I know DF. I can just plus them. 3i, 5j, and 4k. Find the length of OF, which is easy. OF equals to square root 3 squared plus 5 squared plus 4 squared, and that's a square root 14. That's 5 root 2. M is the midpoint of FG, okay? M is here, midpoint of FG, M is here. So what's OM? OM equals to OF plus FM. Okay, OF equals to OF plus FM. So OF is here. We already know that. But FM equals to half of FG. FG is parallel to OA, but opposite direction of OA. So that's negative 3i. FG is negative 3i. So half times negative 3i is negative 3 over 2i. So 3i minus 3 over 2i, that's 3 over 2i. J and K stay the same. That's OM. And for the second one, we want to find the absolute value, magnitude of OF. We just square all these three numbers and find the square root. You can put that into the CAS to work that out. If we have a look at example 8, just wait a second. If you can look at example 8. Okay, if A, B, C is given coordinates of A, B, C here, if I want to find OA, so OA will be 2i minus 4j plus 5k. The second one, if I want to find AB, AB is AO plus OB. So AO is minus OA, so minus 2, 4, and minus 5 plus OB. OB is 1, 0, minus 3. So what I can have is minus I plus OJ minus 8. Okay, and then we have number 3 is BC. BC is BO plus OC. BO is minus OB, so OB is that, minus OB is minus 1, 0, and 3. Plus OC is 1, 3, and 7. And equals to, so that's 0 plus 3j plus 10k. That's A. So B, M. I want to find M. I want to find M coordinates. So I need to find OM. Okay, so M is the midpoint of AB. So I need to relate that to A of B. So we have that. So if AB is like this, M must be here. So OA, we know what is OA. It's 2 minus 4 and 5 plus M is a half of AB. M is a half of AB. We know AB is minus 1, 4, and minus 8. So what we work out here is 2 minus a half, that's 3 over 2, minus 4 plus 2, that's minus 2, 5 minus, that's 4, we have 1. So the coordinates of M will be 3 over 2, comma, negative 2, comma, comma 1. And for C, we want to find F such that OF equals to 2 over 3 BC. So BC is here, 0, 3, and 10. So we have 0, 2, and 20 over 3. So the point F is 0, 2, work out G. So I need OG. OG is OA plus AG. And OA is 2 minus 4 and 5 plus AG. AG is 3BC minus AB. So 3BC is 0, 3, and 10 minus AB. AB is minus 1, 4, and minus 8. Okay, we have that. Plus 2 minus 4 and 5 plus 0, 9, and 13 minus negative 5, 4, and negative 8 in the bracket. So we have 2 minus 4 and 5 plus plus 1, 5, and 38. Then we have 2 plus 1 is 3, 1, and 43. Hopefully I don't have any calculation errors here. If you just follow the calculation, it should have something similar to this. So the point G will get 3, 1, 33. That's the coordinates of G. And the last one is talk about the angles for vector OA. So OA equals to 2I minus 4J plus 5K. We talk about the three angles made with x-axis, y-axis, and z-axis. So if we go cosine alpha equals to, we need to work out OA as well. OA equals to square root 4 plus 16 plus 25 is square root 45, 3 root 5. Cosine alpha with the x-axis is 2 over 3 root 5. Cosine beta equals to minus 4 root 5. Cosine gamma equals to 5 over 3 root 5. Okay, if you go here, degree form, correct to 2 decimal places. So we will have sine inverse 2 over 3 root 5. So 72.65. 72.65 degrees. And then we have beta equals 2. So we can copy this down and change that to minus 4. 1, 2, 6. If more decimals, 126.60. And then gamma equals to sine inverse 5 over 3 root 5. 41.81. Okay, that's how we can calculate the angles formed by the x-axis, y-axis, and z-axis. So I need each individual values in front of IJK, and I need the length of OA. You can try example 9 by yourself. I will stop here. So by the end of today, you should complete all the exercise A and B. If you have any